Hey, thanks for stopping by. While you're here, let's go ahead and talk about formalizing relations and functions. And let me kind of talk about what that means. So our main objective today, we got a few things going on. We're determining whether a relation is a function. Okay, so we're trying to see now as two things relate to each other, are they a function? And then we're going to go ahead and find the domain and range of that relation. And then we're also going to use function notation. So we got a lot going on, so go ahead and have a seat and let's get comfortable and let's learn some stuff. Now keep in mind, I have this crazy feeling that you're going to need some graph paper. Yeah, so grab some graph paper. We're going to be doing some graphing today. You're also going to want a straight edge because now these things that we're working with are solutions to equations. So we don't want to just sketch a line. We do want to actually draw one. Okay, so here's three definitions you're going to want to be comfortable with. So when we talk about them, when I say them, you know what I'm talking about. Now, a relation is a pairing of numbers in one set. Okay, so it's two numbers that are interacting with each other. As one changes, so do the other. It's a relation. A relation is often represented as a set of ordered pairs. So relations are often seen like this. This is how we see them. Now, the variables will change because we might be talking about different things, if it's weight or money or different things. So the variables will change, but ultimately it is the relationship of two things, x and y. Now, part of this relation is we have a relation is looking at the two things, the x and y and their relationship together. So a part of that relation is called a domain, and that's all part of one set. And then we're going to look and see the relationship with another set, which is called the range. So we have two sets of numbers. Part of them is the domain, part of them is the range. Now let me simplify this a little bit. The domain part of this, the domain part of this is going to be the set x. So I'm going to have a bunch of coordinates, or I'm going to have a set of x values, and those are all my domain, and my range is going to be my y values. And we'll see that play out a little bit in a few slides here. So for instance, identify the functions using mapping diagrams. Okay, it kind of looks like a Venn diagram, but these are mapping diagrams. We're not looking for necessarily the overlap here. Identify the domain and range of each relation. Okay, and these are the relations. Relations are an ordered pair. Represent the relation with a mapping diagram. Okay, so if I'm going to look for these things, so first I'm going to look for my domains. My domain is all my x values, so -2, 0, 4, and 5 right here. Okay, my range is going to be my y values. So 0.5, 2.5, 6.5, and 2.5. Okay, now my last thing is I'm going to go ahead and determine if my relation is a function. Now remember, really the thing about a function is each input has exactly one output. So I'm going to look, and -2 goes to 0.5, and 0 goes to 2.5, 4 goes to 6.5. Now really, my range, I've already used 2.5 once, so I'm not going to write it again. I only write it once, and 5 then goes to 2.5 again. Now, when I look at each one of my domains, my x values, 2, 0, 4, 5, each input has exactly one output. So, is this a function? Yes, it is. It is indeed a function because each input has exactly one output. All right, so my domain is -2, 0, 4, 5. My range is 0.5, 2.5, 6.5. Okay, let's look at a second one. My domain is 6, 4, 6, 5, so 6, 4, and I've already used 6 once, so, and I'm going to put them in order, so let's see, 6, 4, 5. That's my domain. My range is 5, 3, 4, 8, 5, 3, 4, 8, 5, 3, 4, 8. Now I'm going to go ahead and determine if this is a function or not. Look at their relations. 6 goes to 5, 4 goes to 3, 6 goes to 4, and 5 goes to 8. This input right here has two outputs, so this is not a function. I would like you to take a turn now. Press pause, and you're going to go ahead and do this. Represent each relations with a mapping diagram. So, yep, you're going to go ahead and do those two circles. Map them out. Go ahead, give me the domain, give me the range, and determine if it's a function. Press pause. All right, if you did not work these out, go ahead, press pause. You've got to try these out. They're fantastic. So number one, our domain is 4.2, 5, 7, and we already used 4.2. Range. Okay, and this is not a function because 4.2 is kicking out two y values, two ranges. The second one looks like each one is kicking out a different one. And keep in mind, yeah. Look at that. Okay, so this is totally a function. Each one is kicking out its own. Another way to decide if a relationship is a function is to analyze the graph of the relation using a vertical line test. You're going to love this one. Now this comes when you have a graph of it. So we're going to go ahead and plot these things. The main thing with the vertical line test, if any vertical line passes through more than one point on the graph, then you're looking at something that is no longer a function. So I'm going to press pause and plot these out. Okay, for these guys right here, is this relation a function? I'm not actually connecting the dots at this one. I'm just looking at the different points, the different coordinates of these, and after I've plotted them, I am seeing using the vertical line test that when I draw a line, it does go through more than one point. This thing is not a function. But it does have domains. These are domains. These are the domains, and it does have ranges. So I can still find domains and ranges of functions. And keep in mind, -4 is written twice, so make sure you only list that once in the domain list of domains. Okay, I'm going to go ahead and press pause and work this one out so you can take a look at these. Okay, as I plotted these out, keep in mind, this guy right here, I had to be really sensitive to that one. Like for instance, when I plugged in -2, this is negative of -2 squared plus 3. So that's -2 times -2, which is going to be 4 plus 3. So negative of 4 is -4 plus 3. So just keep an eye on what's going on with your parentheses and when you're substituting in for exponents, and that ends up being -1. And so when I plot this out, I end up with a parabola, which you want to start seeing when anytime a square shows up, you know you're going to be looking at a parabola, and the vertical line test shows me that really my vertical lines are only going to go through one point. This indeed is a function. All right, go ahead, grab some graph paper, press pause, and I want you to try it on these two, A and B. Plot them out, even if you can recognize them early that it's a function or not, which is fantastic. You should be able to do that. But go ahead and graph it out and prove it using a graph. All right, when I look at these two in graph A, these are just plotted points, and I see according to a vertical line test that this indeed is a function. For B, it does actually go through right here, this guy right there. It goes through 2 points. This one is not a function. So we've got a yes for a function, and we've got a no for a function. But for each one of these, they both have domains, and they both have ranges, and they both are relations. So let's go on. The plot thickens. You have seen the functions represented as equations involving x and y, such like this very common equation, y equals -3x plus 1. But we're going to go ahead and start using function notation for each one of these. And what happens in function notation, what happens is the fx replaces the y. So you can see that right here. Wherever my y is, I'm going to put f of x. So it's f parenthesis x close parenthesis. And that's read as f of x. The letter f is the name of the function. It's not its own variable. It's not like an unknown. But what it is it indeed is just telling us that this is a function that we're looking at. The function notation is used to emphasize that the function value depends on the independent variable of x. So independent variable, this solution is dependent, which is my y. This solution right here, this function, is dependent on what's going on with my x. So as I find my x, I solve things, and I end up with my y solution, or my answer to the function. So we're going to try that on this example right here. The function w of x, okay, represents the number of words, W, that you can read in X minutes. So the number of the words that I can read is really dependent on how many minutes we're talking about here. So my function, W of X, is dependent on this. So I can solve that out. 250 times 8 minutes. And so the words I can read, 250, that's so funny, that's 2,000. All right. I want you to, I think I want you to try it out. Right in the range? Oh, what? I don't let you try it out? All right. That's a big thing. So the main thing for this guy is just keep in mind that when you start seeing something like this, function of x, you're actually looking at y equals. So it's just different, okay? But as we move further on in our maturity of algebra, that's how we're going to start seeing functions. Finding the range of a function, okay? So the domain f of x equals, so here's our equation. Remember, this is actually y equal, this is what you're more familiar with, okay? Y equals negative 1.5x plus 4, but we're now seeing it as a function, okay? And this is our domain. So our domain, right here, is our domain. So we're going to plug it in, 1, 2, 3, 4. So when you guys have built in those t-charts, anytime you put something in the x value, you're actually creating the domain. And now we're going to do the range, which means I'm going to calculate those. Let me pause it and calculate those out. All right, when I substituted in my 1, 2, 3, 4 into my equation, so once I've substituted my domain in, I was able to find my range, which is these guys. So my range is 2.5, 1, negative 0.5, and negative 2. And one little nuance that you want to keep an eye on with these things is once I have it, I go ahead and rewrite it in order. Okay, final step is rewriting it in order from least to greatest. Very nice. All right, I want you to try it out. Ooh, g of x. Yeah. All right, so we've got a function here. I've got my domains. I want you to find the ranges. Press pause. All right, when you substitute in 1, 3, 5, 7 into x, these are the different solutions you get. Negative 8, 0, 8, and 16. You might have got them in a different order, but I rearranged them from least to greatest. So these are my domains. These are my ranges. And if I look, there's no doubles here, so this indeed is a function, and it should be, because we're saying a function of x. So we already know this is coming out as a function. All right, we're almost done here. Identify a reasonable domain and range. Okay, so you have 3 quarts of paint to paint trim in your house. A quart of paint covers 100 square feet. Here's the function. That's where you're going to be using it. It represents the area in square feet that quarts of paint cover. So we can see right here, the quart of paint covers 100 square feet. And what's a reasonable function? And what is the graph of this function? All right, I went and put the graph together on this one. I kind of t-charted this a little bit over on some scratch paper. So if I knew that if I had 1 quart, it was going to cover 100. If I had 2 quarts, it's going to cover 200. If I had 3 quarts, it's going to cover 300. So there's my range and my domain all built out there. And when I look at this, I can see that I have 3 quarts of paint. So when I'm working with this one, I can see that my function is telling me that a quart of paint, let's see, my range. So my quart of paint is going to cover at least 300 square feet. So it's 300 feet or less. That's how I want to put this out here. So let's see, what is the domain and range? What domain and range is reasonable for this function? What is the graph of the function? Okay, so our domain, so here's our numbers here. We have our 3 quarts of paint domain, and my range is really going to be less than 300 or less. So I can say that my range is going to be less than or equal to like 300 is what I'm working with on this one. So I can paint anything up to 300 square feet. All right. hey, keep practicing this stuff. It'll go great. The language will come really easy for you too as you keep hearing it. As you start seeing function of x versus that y equals, that'll go all really smooth. All right, well, you have a great rest of your day. I'm going to go and make a lava lamp out of cauliflower and bananas. Ooh, and a liquid. I'm going to use raccoon sweat.